Hey, welcome everyone to this Learn the Tech show. And sorry for last week. My tech guy duties prevented me from actually preparing a show. My tech guy duties also kind of prevented me a little bit today, this week also. But you know what? I really wanted to do something, and I thought, well, even if it's just superficial and we don't dive really deep, just as long as we talk a bit about technology and it's a show that I want to maintain. So we're going to talk about space exploration, about the universe. We're going to talk about technologies that are used in here. And so this is Learn the Tech, show number 14 for May 3rd, 2014. 2014. Wow, I'm back in time. I'm in a time machine, 2016. And well, welcome to the show today. So we'll talk a bit about space exploration. It's a subject that I particularly love, and I can tell you that space exploration for me is something special. I mean, as I was young, um, as long as I remember, I was looking up at the sky and just being amazed at the stars, and there was something drawing me towards that. And I guess that's why my first studies were in applied sciences. Before I studied electronics, I studied computers and stuff, but the first studies that I've ever done were applied sciences. Why? Because I wanted to, maybe go into that field of astronomy or some kind of scientific, physician, or I don't know, and it runs in the family. My nephew, one of my nephews is actually uh, at the university in physics. So I think it's something that's very important to us. And there's a lot of stuff that people don't know about space exploration. Unfortunately, a lot of the space exploration side of our society is it's something that people just don't grasp, and people have a lot of difficulty understanding why do we go into space, and why do we need to find other planets? And one of the things that people don't understand is that our own solar system, our own Earth, is not something that's going to last forever. The sun that we have every day is going to extinguish eventually. It's halfway through its life right now at about 5 billion years old, 4.5 billion years old. And one day humans will need to find a way to escape to some other place in order to survive. And here we're really scientific, not talking about God or anything. So there are some technologies, some stuff today that people don't know comes from space exploration. TV dinners. If you're eating a TV dinner right now, or if you eat TV dinners because you're at work, or well, these things comes from space exploration. These were made for astronauts. And so someone said, hey, these could be cool to prepare and sell to people. Why not? Another use of a technology that was from space exploration is the microwave oven. Now, the microwave oven started off as an accident. A team was actually trying to fix a radar, and the antenna of the radar was actually pointing towards the person that was testing it. And in his pocket, he had a sandwich. And he was amazed because he suddenly noticed that when he took his sandwich, it was warm. And he kind of made 1 + 1 = 2, and he noticed that the radio waves coming from that radar were heating up his sandwich. And he patented something that would be called some kind of cooking device. But the first real use was NASA. NASA had the first microwave devices aboard spaceships so that the astronauts could eat up food. And of course, it became mainstream, and everybody, or pretty much everybody, has a microwave oven today. So beautiful space, very vast, very amazing when you think about it. So the first ever thing that happened technology-wise that is of importance. Now, of course, we can go back in time, think about when Galileo decided that his telescope, telescopes were existing at the time, but Galileo is the first one that thought, hey, what about if I use it and look at the stars with it instead of looking at ground objects? And one night he pointed at Jupiter and saw that there were little points next to Jupiter. And he started looking each night and noticed that the points were changing place. And he started thinking, hey, these are objects that are probably turning around Jupiter. And, it opened up a lot in astronomy, in the field of astronomy. Of course, the bad side is that religion came into place. And because he started saying that, well, from what I observe, I don't think Earth is the center of the universe. He got kind of, in a bad rap with the church, and he finally had to just shut up. But it was a major advance, and there's a lot of these little things. So these are the basic technologies, of using a telescope, using basically lenses, and knowing that they amplify everything we see when they're shaped in a certain way. And basically, we go on. There's discoveries. Telescopes become bigger. We notice the bigger they are, the more they get light, the more they see far away, because the dim objects, not always, but most of the time, the dim objects are farther away. So you got to find a way to see these objects, and it's with telescopes. The first biggest advance, I would say, in technology in a space exploration is when Sputnik. We're in 1957, and it's the Cold War, and the Cold War as one thing. If we have one positive side to the Cold War, is that all the money spent in technologies for the military use and for all sorts of, making bombs and everything. The positive side of that is that it also brings new ideas of how to do stuff. And one of the new ideas is, hey, we can send something in space that will orbit the Earth. And that happens in 1957. And, everybody's really, really amazed. I mean, even I would say the United States is totally shocked, because they're like, what the hell? We thought we were advanced. We thought we were really advanced compared to the Russians. And no, the Russians have a major advance with this thing. It means that now they can master the possibility of orbiting Earth. And that's something that, takes a lot of preparation. You need rockets. You need to have the power to send something out of the atmosphere. And you need to calculate exactly how that's going to happen. And, we're in an era in 1957 where we're getting close to something. We're getting close to technology that's smaller. But you know what? We're still in old technologies. We're still using vacuum tubes. But computers exist. In the 50s, computers do exist. They exist in the form of super calculator machines that are basically, they take a full building in size. They have tubes, and they aren't computers like today. They're more of big calculators, and they're there to calculate the most you know, at a faster rate than the human mind, basically. And they do it. You know, I mean, they're old and they don't do much when you compare it to today. But you know what? They make these calculations at a much faster rate, so they're able to help humans uh, make complex calculations to do stuff like this. And a little story that I have with that is, um, you know, when we talk about a computer bug, the reason why it's called a bug comes from computers in the 50s. And the simple, the funny story behind it is that one day there's this guy that is checking out, you know, the supercomputer they have, which is basically a big calculator, but you know, they're using vacuum tubes. If you've seen an old TV and an old radio from the 50s, or you know, there's these little glowing tubes, and these essentially are what transistors are today. And there's a failure of the computer. So he has to go and take a look where it happened and what happened. And there's a bug, a fly, that actually stopped on one of the tubes. And the tube was so hot that he kind of burned right there on the tube. And it actually cracked the tube, which means that the tube failed because of that. And he changed the tube. And when they ask him what happened, he says, well, there was a bug. And that's where it comes from. The story behind why we call it a bug in a computer comes exactly from that story, from the 50s, when there's this little bug that basically made the computer, a whole computer fail. And it's just a funny little story that, you know, not a lot of people know. And I like little details like that, you know, of things that happen and why something's called the way it is. Why do we do that, and why do we call it like that? So we're at Sputnik era, and now we're mastering with computers. And what you see here is an actual picture of the NASA room in early 70s. All the screens, all the computers, which are basically big calculators. You know, they're not really processing that much information. They're just making calculations based on data that is coming in to let the humans know of the state of, you know, the technology they're using. And most of it is still done by the human. I mean, these computers give out just numbers. And the human behind the screen is the guy that knows what the numbers mean. So he can extrapolate. He can say, well, okay, according to these numbers, well, there's a failure in this circuit here, or there's something wrong there, or that is fine. That's okay. So, you know, it's very basic computers. It's just in and out data, checking out and making calculations based on all of that to let the human know that, well, we're within range of something, or it's working, you know. And basically, the first thing that happens, and that's of importance after that, is putting a man on the moon. Putting a man on the moon was one hell of a feat. You know, we're in 1969. Just try to remember that in 1969, we're not talking about Apple computers. We're not talking about, you know, Intel, and we're not talking about Microsoft doesn't exist anymore. You know, it's like it's the beginning of something. And to achieve this, of course, it means computers are slowly getting more complex, and they're doing a little more tasks, but they're still very basic. You know what? The computer in the lunar module and the computers in the spacecraft that they have is approximately as powerful as a scientific calculator today. Not even. I would say that even the scientific calculator today, which you can have for a few bucks, is probably more powerful than what they had in their machines there. We're still heavily relying on human brain, human mind, and understanding much more than on computers. Computers are there, they help, they make some calculations that make our lives a little easier, but still, the human is still very, very, very important in all the decisions and all the things that are there. But all of that is possible because of one very major breakthrough that happens in the 50s, in the late 50s. And the late 40s, sorry, I'm really sorry, it's the late 40s. I'm 10 years too late. In 1947, there's scientific people at Bell Labs that are working on something. They've noticed that common sand, which is silicone, has a very, very unique property when it's correctly cleaned up, so purified somehow, and plugged in a certain way. And when you do pass an electric current through it, it acts like a switch, because a transistor at its most basic use is an on-off switch, an electronic on-off switch. And that is used a lot. Computers of today work still with transistors. I mean, that discovery is in 1947. We're still using that today. Okay, the difference is, look, in 1947, this is an exact replica, by the way, of what it looked like when they tried it out. This is huge. I mean, this is a huge transistor. But it doesn't take very long that they can use this and miniaturize it in a way that it becomes very small. And it has all sorts of applications. In the 50s, we start having the first transistor radios, which are very small and work on batteries, and everybody's amazed at these devices. And that changes the course of the future for technology in a major way. Today's computers rely on millions and billions of transistors. I mean, today's CPUs have hundreds of millions of transistors. Some have billions. The Intel Core i5s, i7s today have billions of these little transistors, of the very miniaturized. The only thing that we changed, basically, from 1947 to now, is how small it can be. Today's transistors can be, they're not much bigger than a few atoms. But think about it, they're so small. Imagine the machines that have to actually build those things. But this changes everything, because from now on, we don't have to use a vacuum tube. We have a small little device, and we can put many of them together to do something. So we've got the on-off switches. We've got another property of the transistor, the ability to actually increase a signal. So you can take a signal that's very weak and make it much stronger. That's what an audio amplifier does. If you've got a Wi-Fi, Hi-Fi system, a stereo, or any radio that you're listening to has an amp that actually amplifies the audio to make it strong enough for you to hear. It's all made by transistors. These are the devices that were invented in 47 and that are still in use today, and heavy use. And I mean, they are amazing. Now, there's all sorts of transistors that were also invented on the way, but they all share the same common basic features, and it comes from there. So technologies to watch the universe. What do we have also? We have telescope. This is the Palomar telescope in California. Palomar Telescope. I remember when I was, I don't know, about 10 years old, and starting to read astronomy books, and how they're telling me how this Palomar Telescope is, state-of-the-art, amazing telescope of the 70s, because this thing is just amazing back in the 70s. But it uses part of old technology still, because we're in the 70s. There's a lot of stuff that's not invented totally yet. And we're going to come to some interesting inventions that we're using every day, basically, and we don't really know it. So it's mostly, optical, using, like Galileo. Basically, this telescope is a giant telescope like Galileo used in the 1600s. But it has so much more size that it can take in much more light, meaning we can see stuff much farther away, much weaker. And it uses mirrors because there's new technologies that actually now make the possibility of using a telescope with a giant mirror and focusing everything on a little point where, at first somebody's looking at it. Of course, they're starting to use some technologies like cameras. But, we're in the 70s. These are big, clunky cameras that aren't that fantastic. And, there's need for more. We're still back then, and this, by the way, is the original photographic plates of when they discovered Pluto in 1930. So Palomar still uses that technology, photography, where you take a picture, a long exposure picture of the sky, and wait till you leave it there for many minutes to hours, so that it can actually receive as much light as possible and see something. And we discover a little dot that's moving here. That dot is moved because you might ask yourself, but how do we know that this is a planet, and why is it moving and the other things are not moving? Thing is, planets in our solar system are moving at a speed that is much bigger than the stars that are very far away. And the reason why is because it's close and they're orbiting the sun. So yes, the stars you see here are moving, but at such a slow pace that, over 24 hours, over a month, you won't see a difference on photographic plates. But planets in our own solar system, at the speed they're moving, we see the difference. They've moved. So now it's like, hey, there's something here and here, and they have to compare. It's very amazing. They have to compare these things. And, Palomar in the 70s is still running on these old technologies of photography. It's just, the thing of the time. But something happens along the way. And thanks to transistors, thanks to capacitors, to electronics in general, you know what? They're using something called a CCD. That is something brand new, and it appears somewhere in the late 70s. And the CCD, back in the late 70s, is a huge device, super cool. You need to really keep it in extreme temperatures for it to work well. And that is what now we have today in our cameras, digital cameras, in our smartphones. And you know what? It hasn't changed much. But, I have a camera here. Front, back. This uses the same technology of CCD that astronomy uses in 1978, 79, when it starts to really get there. But back then, it's super cool. It's very complex. It has a high rate of failure. And CCDs will change forever the way we look at space. Because with CCD, we get even more sensitivity than we had with photographic plates. We are able to take these devices and bring them to a point where they are really getting almost each photon of light coming through. And these become the standard of watching the sky. So that's another application. Astronomy has brought us applications that we use every day. You know, that's what people don't understand, I think, about astronomy, about billions being spent in all of that, watching the sky and trying to find life somewhere else. It's that it eventually has an application to devices like this. You know, another thing that is very important, this is huge, but needs to be miniaturized and to a point where it's so small that it's available in a small portable device, digital camera, smartphone. Well, that also brings us miniaturized technology that, I mean, this thing is so powerful. This is a Galaxy S7 phone. This is so powerful compared to pretty much everything up to the early 2000s. And look how small it is and how amazing these little things are and what you can do with them. This replaces a desktop computer. It's just so incredible. It does replace a desktop computer when you think about it. And it's thanks to these technologies that, of course, they're breakthrough, but they need to be miniaturized because we need to include them in devices. We need to include them in spacecrafts. We need to put them everywhere. But for that, they have to be small. And as they're getting smaller, they're also getting better. You know, we need to have these, but we need to have these in a way that we don't have to have a super cool environment, and we just need to have the best way of doing it without any special hardware needed for it to work. There are different ways also that CCDs change our look to the universe. Photographic plates were on the visible side of our universe. Photographic plates basically see what our eyes see. And that meant we would see the universe in only one way. You know, it's like, I would say, you're looking through a filter, a colored filter. So you've got these yellow sunglasses and you see everything in yellow. Well, you're missing out on stuff. You don't see that the sky is blue. You're limited in your range of vision, what's possible. And the universe doesn't just emit photons. The universe emits all sorts of extra radiation. One is infrared. And what is interesting in the CCDs, the charge coupled device, as we call them, is that they can be tweaked to view at different wavelengths. So they start looking at infrared. They can look at the ultraviolet side of radiation. The two edges of our vision. When our eyes are actually watching something, the range of colors we have goes from red at the extreme low end to the blue, which is at the extreme right end of the spectrum. The problem is we don't see it, but for example, that feeling of being warm when you're in the sunshine isn't the light. That's infrared. Infrared is giving you that warm feeling. You feel that it's hot. Now, CCDs, your eyes don't see that radiation, but CCDs can be tweaked to see that radiation. So now it brings a different universe. It brings a universe in a way that we've never seen it before. It changes our perspective on what we see also. At the other end, we have ultraviolet. Once again, these are super energetic particles. And they're at the other end of the spectrum. Our eyes don't see it. But, you know, if you ever been on a hot summer afternoon for a few hours without putting any protection, solar cream protection. You've seen what ultraviolet radiation does. You're burned red. They burned your skin. Why? Because that UV radiation is very energetic compared to regular light. So since it has much more energy, it actually interacts much more with living organisms. And so CCDs are meant to see that, and they change our view of the universe forever. Other technologies that are used in space, exploration, and also in what we want to see is radio. Radio is a form of electromagnetic radiation, as is light. Light is a very, very unique thing. It has two properties. It's a particle, but it's also a electromagnetic radiation at the same time. It's a very, very unique thing. Radio waves act a little bit like light and are at very different frequencies. And so we have these radio telescopes, which basically is a very big antenna that focuses the maximum of energy from a radio wave. It's similar to a telescope, except that instead of receiving light, it's receiving radio signals. And the bigger it is, the more radio signals. Just like a telescope, the bigger it is, the more light comes in. So basically, a radio telescope will receive radio signals from space. First use of radio telescope that is amusing is in the Second World War. At the end of the Second World War, we're starting to have radars, and it's the first time that we use radars in detecting enemy planes, enemy ships. It's pretty new technology. One day, this guy comes up, and he has to tweak the radar to make it work correctly. Points it up, and first thing he says is, "Well, I think it's broken." And the other guy says, "Really?" He says, "Yeah, I think it's broken because I hear noise. I hear a thump, 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 thump signal. So there must be something wrong with the circuit." He spends the full day dismantling it, looking at everything, putting it back together, changing parts, puts it back up. He still hears the thump, 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 thump. And he's wondering, wow, it doesn't seem to be broken. I don't understand why I'm receiving this. He moves it, and it's gone. There's no more noise. So he's like, it puts it back in the same position, and he hears the signal again. And that's where, for the first time, we understand what we're hearing is a signal from space. It's not man-made, it's not from here, but that device is sensitive enough to receive a signal from space, and it comes from a star. There's what we call pulsars. Pulsars are very highly magnetic, energetic magnetic stars, magnetrons, and basically they actually the speed at which it turns on itself is so high that some of them spin at 20, 30, 50, 100 RPM. And they have a point where there's a lot of radio energy that is sent. So when that points towards Earth, we hear it. And because they spin pretty fast, all we hear is thump, 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 thump. Very, very cyclic thump. Actually, they're so precise that you could actually have better precision on your clocks using that than using an atomic clock that we have today. It's of an extremely precise nature. And that's the start of radio astronomy, where we understand that, okay, so we can listen to the universe. We watch the universe in different frequencies. We've watch with our eyes, we can listen to the universe. But not just that, these can be also used to make a map, because with supercomputers now, you can take that signal and make a map of the radio environment of the universe, and you can make out the stars, you can make out the galaxies, you can make out everything as if you were looking at it. It's just different because the radio side of the universe is different than the visual side. And so it's very interesting to note that. So radio is used. And radio is invented here in the 1920s, the first transmissions. And you know what? A radio telescope is also used by something called SETI. SETI is a search for extraterrestrial intelligence. They use radio telescopes and they listen to specific areas of the sky in search of something unusual in the radio spectrum. And the logic behind this is, well, we've been transmitting signals since the 1920s, and the first signals that probably went into space are somewhere in the 40s, because we started transmitting in a higher frequency range where our signals got lost into space. So we're thinking, oh, we've been transmitting towards space for 70 years now. And so maybe some other civilization somewhere has been transmitting signals for a long time, maybe even a longer time than we did. So that's where we get the, SETI. One quick story about SETI is a signal. In 1977, the Big Ear radio telescope. In 1977, things are starting to get computerized. So there's a computer printout, and there are some numbers on this. And the guy notes one series of characters and writes "wow." And if you guys or girls are curious, you can search for "wow signal," and you're going to see that in 1977. We've heard something. It's still, a lot of debate of what it could be. Some local Earth interference, some spurious signal generated by the Big Ear telescope. That is all possible. But there's still no logical explanation pretty much of what that could be. And the way that it presented itself, because the Big Ear telescope has like 2 ears. So when you hear something on one side, as the Earth turns, because the telescope cannot turn, it's fixed, you should hear the same thing on the other side approximately 60 seconds later, or something like that. I don't remember the exact time. So they hear it once, it fades away. They hear it 60 seconds later on the other one. So it must be something from space. Unfortunately, later tries, and I mean, they've done dozens and dozens of listening on that particular part of space and never heard anything again. Who knows? It could be equipment problems, could be something happened, could be the computer just went berserk. Maybe it's a signal from somewhere. Who knows? Who knows if life exists? Space exploration uses a lot of technology, because in 1978, we have a pair of 1978, we have a pair of spacecrafts that we're sending out. And these are meant to go through the solar system. The Voyager spacecrafts, Voyager 1 and Voyager 2. And the Voyager spacecrafts are actually the farthest objects that we have ever sent in space right now. They're still working. They were sent in 1977, and they're still working. So imagine next year is going to be 40 years, and they're still working. Why they're working? Because they have nuclear reactors, basically giving power. And they're really far. They're farther away than Pluto. They're actually, Voyager 1 is probably outside of the bubble created by the sun of our own solar system, which is very interesting. It's the first time we have something so far away. These use different types of technologies now. They use better computers. They use the first microprocessors, because now we have microprocessors. Intel, releases the first microprocessor in 1970. Basically, now there's processors, and NASA and the Defense Department, they have access to the technology way before we do. So basically, the spacecrafts have technology that we won't see available for regular folks like us, maybe up to 10 years later. So they're like the first much more powerful PCs running a program. And also, they are the first robots. There's, cameras that can move. There's the first real side of a robot. It comes from space exploration also. So these are being sent out and controlled. And at first Voyagers, the Voyagers were only meant to visit Mars, not Mars, Jupiter, Saturn, and that's it. But you know what? They sent it to Jupiter, they sent it to Saturn, but in 1980s, there's a phenomenon that doesn't happen very often. The planets are almost aligned on the same side of the sun. And that creates a very unique opportunity. Some researchers, they just think, if we use Saturn's gravity correctly, we can slingshot towards Uranus and do the same with Uranus and slingshot to Neptune. And that's why we have Jupiter, Saturn, Uranus, and Neptune that have been visited. Neptune was the last one. It was in 1989, if I'm not mistaken. I remember I was 15, 14 years old, and we had seen Jupiter and Saturn, and I remember thinking, oh wow, in 1986 we're going to see Uranus, and in 1989 we're going to see Neptune. And I remember being so amazed at that. It was just so cool. But these are the first devices that use charge coupled devices, the same sensor that you have in your phone for a camera. They use, of course, radio. They use the first microprocessor chips. And they use the first robotics. Basically, these are the first robots sent into space, basically. Very basic compared to today, but they are robots. And of course, that advances more and more as technology advances, as we get more powerful chips, as we get more powerful computers, as we get computers that take less power, much stronger cameras. Well, we build these things. So there's, Curiosity on Mars that's going on the planet. These are much more complex robots. These are much more complex devices. And they use the latest technology in order for us to, see what's on the surface of another planet. It's just incredible. And they're very robotic. They use the latest technologies in robotics. They have powerful computers. They use the same kind of technology pretty much we have in our computers. These have, Intel chips and stuff like that. They have Intel CPUs. Why? Because they're widely available. They're extremely powerful. Why not use regular technology? Going to cost less to build that robot, and it's still going to work. They use very powerful, the high-end, digital cameras to explore the surface. Of course, they have to be shielded for radiation. They have to be shielded for the temperatures, because temperatures on Mars are very cold. In general, the average temperature on Mars is more like -50, -60, -70 degrees Celsius. So that's kind of really down, and it drops below -100 sometimes. So, it's shielded, but it's pretty much technology we use today. Space Shuttle, which was retired following the unfortunate disaster of Columbia's re-entry in 2004. This space shuttle is still, as of today, the most complex device humans have ever constructed. This is just incredible, and it's one of the reasons why also probably not flying anymore. In science and in all of the things that we do, we also want to think about one thing, try to keep it as simple as possible. And this thing is extremely complex. Maybe that's why it failed at 2 occasions. It's just too complicated of a device to manage. It's also extremely, extremely extremely prone to all sorts of problems and of computer crashes and everything. Is just way too fragile, basically. And the space shuttle got upgraded several times so that it could update all its system for the latest system. But it's interesting to note that this is one of the most complex things that we've ever built. It's pretty cool when you think about it again. So that's pretty much the space exploration for you. Search for life in the universe. Is there life in the universe? I think there's life in the universe. And we got to be careful. Life does not mean there's somebody like me making a live show on some other planet's internet network. It could just be bacteria. It could be viruses. It could be animals. Who knows? Maybe there's a cat planet. That would be a good YouTube planet, the cat planet. And basically, the search for life in the universe uses a lot of the technologies of powerful computers today. It uses the ability of taking radio, because a lot of it is done on the radio wave side. For now, we're still thinking that radio is one of the best ways that we'll hear or see or know if someone's out there. Maybe we're looking at the wrong way. We're not really sure about that. The search for life in the universe relies on very powerful computers. When we look at computers today, you can see that computers have more and more, with the power they have, the ability to actually give us details about things that seem like there's nothing there. So, all the technologies we're using, the signals we're receiving, the internet, the Wi-Fi, these are all capabilities of a computer taking something, looking at what's around it, which is kind of noise, and saying, no, that's what I want, and that's noise. Well, more and more powerful computers can remove more and more noise from everything and leave intact the information. For example, we're talking about the Voyager spacecrafts. The Voyager spacecrafts are billions of kilometers away. The transmitters are very, very weak. So we're using the ability of pointing a radio telescope, removing, which is probably 99.9% of noise, and still getting that little data stream coming from so far away in our solar system. We're using the same technology with the search for life in the universe, but we're using it in a different way. We're not only trying to remove noise, we're also trying to find patterns. In general, the background noise of the universe is a mishmash of chaos. And in general, what humans actually do, our transmitters, our TV programs and signals, that has a pattern in it. It's intentionally created by us, so it has a pattern in it. So in search for extraterrestrial life, what we're trying to do is search for a pattern in here that means some intelligent being somewhere is actually sending us some signal. Or if they're not sending it to us, maybe they're just sending out signals. You know, we're not sending intentionally signals for extraterrestrials here. We're just sending signals. And the fact that it's going into space is something that we probably didn't think about really much. And actually makes some scientific people scared. Because a lot of scientific people say, well, let's say there's life. What tells us that that life is actually good? Could they be bad aliens, like, you know, in Aliens or whatever, and just come here and try, you know, Independence Day? They want our planet and that's it. And that gets a lot of people a little scared because they're like, we're kind of, you know, just transmitting signals and saying, hey, we're here in the universe when maybe we should stay quiet. So we're searching for that capability also. Maybe there's some aliens somewhere here that are transmitting unaware, and who knows? We receive a signal somehow. That's the possibilities. Radio telescopes are, you know, more and more sensitive. There's a very large array in New Mexico. There's the very big radio telescope at Puerto Rico. There's another project right now that is actually getting amazingly big in Australia. And the more and more we're constructing these things, the more we'll be able to pick up very, very, very weak signals. Once again, using computing power. We're not listening to these with our ears. We're receiving something that is analyzed by computer programs that search for certain patterns, which we think would be there if an alien was sending signals. So who knows? But that's our technology that's being used for that. And what's the future? What future technology will we invent that will make that future, that discovery? You know, there's a lot of things we're using. We're at a point where computers are getting powerful enough to detect things that we couldn't see before. We're now able to detect signatures of molecules of oxygen and nitrogen and, you know, all these gases that are in atmospheres around planets, methane and so on. And we're seeing them now from far away. We're starting to see by the very weak wobble in orbits that a star has planets. You know, there's a friend of mine that's very religious, and one day she posted something on Facebook saying, "Oh yeah, we're pretending, you know, we're pretending that there are planets on another star because it wobbles, and you know, there's no proof about planets." Well, I'm sorry, yes there is. There's much more proof that there's a planet around that star than there's a proof that God exists. I'm sorry. You know, and don't tell me the Bible or anything. Bible doesn't mean anything because it's been written by man, and there's no proof. You know, I haven't seen God. None of you have ever seen God. So what I mean by that is, you know, not that there could be a God or not, but more that science is there to explain, and it does explain stuff. Another friend of mine said, "Oh well, yeah, but you know what's unexplained is God." Well, what's unexplained is just that we don't have the knowledge yet to explain it. But give us more time, and we'll get much more knowledge, and we'll finally understand all the things we don't understand yet. It's something we got to think about. And the future technology will get even more powerful. So it's going to enable us to hear weaker stuff. It's going to enable us to view farther away. But we also have to use that technology to ourselves. Understand that we're not eternal, and that someday somebody will have to do like in Star Trek and go into a spacecraft and move on and search the universe somehow, because Earth will eventually not be here, and the solar system will not be some place where you want to live at some point. When the sun dries up all the fuel that it has, it's going to be a damn cold place here, and we're going to, have to go somewhere. And for that, we need to continue on technology. Technology is something that's difficult for a lot of people in the sense that it's moving. People will tell me it's moving so fast. And we have to move at a very quick pace. It's very important. It's not just a question of making money. It's a question of we have to move in a fast pace for our technology in order for us to advance and learn more and do more stuff, and eventually maybe get away from this Earth and find another planet where maybe human beings will live for millions of years again. So, it's one of the things we got to think about. So this was our little presentation, not super, I just bloated out a lot of stuff while I was going on because I didn't prepare that much. But, it's easy for me because space and astronomy, I know a lot about it. I know a lot about the past. I know a lot of the history of everything. By the way, I want to thank everybody. There's some people that were talking about. I've got a lot of comments on my Learn the Tech show when we were going back in time with the internet, where it comes from and everything. And I had many comments about people saying, wow, this is incredible. Your knowledge of not only the technology today, but where it comes from and the dates, and what you say is actually true when we check it out. And yeah, that's the thing. I don't want to invent things while I'm going on. I want to have actual facts that I know of. I'd rather say I'm not really sure of when than say a date or a year. That's for sure. And thanks for the great comments. Thanks to everybody that also gave me great comments about my Learn the Tech show, which was about how we use technology to spy on us. A lot of you got kind of scared, saying, well, it's scary. And I've learned a lot of stuff, and it's rather scary. And what I do enjoy is a lot of people said, you know what? I never thought about some of the things that you said. For example, when you accept all of the conditions for an app to take all the information. A lot of you had never thought about that and said, you know what? You now make me think about what I'm going to do when I have an app. And because I understand a little more the implications of what could happen. So thanks everyone for the great comments. If you have a Learn the Tech subject, why not post it below the video? And we're going to check it out. And of course, make other Learn the Tech shows of everything. Today was kind of cool. We're more into space and stuff and astronomy and how the technology used, and how it also gives us great devices that we're using today, and we just don't know about it. It's like the military. I don't like military spending because it's done in a way that we want to. There's kind of a bad side to it. Yeah, the billions spent in military brought us a lot of technologies we have today, and a lot of things we have in our homes. That's the good side. We have to see the good side of everything. So take care, everyone. This was Learn the Tech. We're show number 14 for May 3rd, 2016. Hope you enjoyed the show. And please, if you like everything I do, don't forget about donations. They're really appreciated. They help a lot. And these hard times where AdSense on YouTube is not paying very much, it enables me to dedicate more time to doing these things. So thank you for those that have donated. And see you next week for live show where I answer your questions next Tuesday, 3 p.m. Eastern Time, 1900 hours UTC. Learn the Tech show number 15 next week. No subject yet. I'm not sure what we're going to talk about. I have virtual reality, but I need to do more research before I talk about virtual reality. And so next week, 6 p.m., Learn the Tech, 2200 hours UTC. Take care, everyone. It was really nice to have you. See you next week. Bye-bye.